Hi, everyone. Thank you for coming. Today, I'd like to talk to you about these two. These two. DevTools and Headless Chrome, and how we can combine them to expand the limit of what we can automate to make web development easier. A little bit about me. My name is Yonatan Mevorach. I'm a web developer. I have 2 kids, along with my amazing wife, whose name, and I swear this is true, is Git. And I have a relative who I've been told that every Swedish person knows because he has his own show on Swedish TV. If you're interested, come talk to me later. I would love to talk to you regardless, and I'll check this theory. I work for Wix Engineering. We're the team behind Wix.com, which is for many years now the most advanced website builder for people who don't know how to code. But recently we've expanded our vision, and now we're also targeting basically small businesses to not only manage their brand and online presence, but also communication with their customers and managing their inventory. So it's an exciting period for us. A little bit more about myself, and this is related to the talk. I really love automating things. I love taking a process that's done manually, that's just boring to do, that's error-prone, that's tedious, and using it so that with code, it'll be done automatically, and no human will have to deal with it ever again. And sometimes I'm guilty of this. Maybe you're guilty of this as well. Sometimes I know full well that taking the time to write the automation will take me longer than I will ever spend on using code to do this manually, but I still choose to do it this way because it's just more rewarding. And another thing that I really enjoy as a web developer is using Chrome DevTools. I think it's an indispensable tool. It helps me analyze and tinker with the web application that I'm working on. And I think that it's the one tool that all web developers can agree that is just the best suited for this job. That's of course not true because web developers never agree on anything, but if they were ever to agree, maybe it would be a consensus about this tool. So today I'd like to kind of talk about the intersection of these things, about automation and web development. And I'm going to show a few things that we can solve in this space. But ultimately, I don't want you to focus on each one. Hopefully, this talk is kind of greater than the sum of its parts. And based on the underlying mechanisms that I will show that work behind the covers of these examples, you can take this and apply this to things that that you think about that are different than what I'll show you today. And so ultimately, our goal is so that you'll never have to say that there's something that you want to automate in web development and that you can't. So when we talk about web automation, what are the things that usually come to mind? Let's do a quick review. If you just say automation to a web developer, the first thing that comes to mind is usually end-to-end testing with a framework like Selenium, perhaps. So this means that to make sure that you're shipping a quality product every time that you change your code, every time you do a new UI feature, you take the time to describe with code how the user is interacting with the screen, how you expect the UI to change accordingly, and you rerun these tests, and then every time if they pass, then it's on to production. Also, there's this idea of screen scraping that you do with the browsers. If you want to extract data from a website that doesn't have a proper API, what you can do is render it. You need a real browser for this because so many of the sites we visit today are using client-side rendering. And so you're able to do a bit of querying the DOM to extract the data in this way. This is something extra that also Wix does. For example, when you create a website on the Wix platform, you basically get a single-page application, which means that when the user navigates inside your application, moving between pages, he would have a really good experience. But if you take the naive approach to this, then it would also mean that the initial loading, when the user visits the site for the first time, it would be pretty slow. So what we do in some cases is there's a browser running in our cloud, and it's rendering the client-side application and sending down the HTML so that you will get a really snappy experience. But like I said, today we're going to try to move beyond these examples that have been around for quite some time. But regardless, for all these things, we use headless browsers. Headless browsers are regular browsers but instead of controlling them with a mouse and keyboard, you use code to describe the interactions that you would like to do onto the page. And instead of rendering anything to the actual display, they just render things in memory. So this makes them really well suited for all these types of automated tasks and testing. We can run them, of course, on our development machines, but really the idea is for these headless browsers to wake up every few minutes or every few hours and perform these tasks in some remote server environment. Now, up until recently, the undeniable king of headless browsers was Phantom.js, but they've recently stopped development, and now we have a new king, and that's Chrome. But not Chrome the way you and I use it every day, but rather Chrome running in headless mode, which is a newish feature. It was introduced in Chrome 59. And now the ability to run Chrome as a headless browser is officially supported. So this means that you don't need any type of hack to get this working. Previously, you could do it by swapping out some operating system level components so that Chrome thinks it's talking to the actual display. Wasn't something that was easy to get set up with. Now it's pretty trivial, and we'll see an example. What we can do with this, we'll see later on. Also, they released a companion library, Chrome, the team behind Headless Chrome, that is called Puppeteer, which you may or may not have heard of. It's meant to be a high-level wrapper for controlling Headless Chrome. And let's see an example of using it. So if you want to get started with it, all you have to do is just a node library, so you can grab it off npm and start using it. So this is the example that we're going to use to illustrate this. So let's say we talked earlier about things that are tedious and we want to avoid. Let's say that after I finish watching a session here at the conference, I find it too tedious to take my phone out of my pocket, and I want to come up with a better way to do this. So what I would need to do is I would want to first extract the conference data from the website, and then do something with it, like maybe come up with a smartwatch app for the conference. And of course, I had to, sorry, this is the JSON that we'll get. And of course, I had to actually build this. This is a perfect example of me taking 2 hours to build this smartwatch app, which I pretty much saved only 30 seconds in total of taking my phone out of my pocket. But regardless, let's see how we can extract the data from the conference website. So this is how we would do it. I'll walk you through the code. First off, Puppeteer, like I said, it's just a normal node library, so we use it like we do any node library by requiring it. Then we will need to call the puppeteer.launch command, which is going to launch Headless Chrome on our behalf. And notice that I'm using the await keyword here because all of the commands that I'm doing with Puppeteer are asynchronous. Then I'm going to call browser a new page, which is the same as opening up a new tab in my browser. Then I'm going to want to navigate to the conference schedule page. I do that just by passing the URL. And I also need to sometimes pass in this extra parameter that's optional that tells it what to consider as the point in time when the page is finished loading. Because in a page that does client-side rendering, this is not always conclusive. So one of the options is to tell it to wait until there are no more network requests for a given amount of time. And that's a good indication that the page has finished loading. Now, after we do that, it's up to us, and there are several ways to achieve this, really, to figure out how we can extract the data from the page. So let's put Puppeteer and headless automations aside for a minute, but just think, how would we approach this if we were using a regular browser, let's say Chrome, that we use as web developers? So what you would probably do is something like this. You would open up the console in Chrome and write this bit of code that uses querying the DOM. The CSS for the Øredev website is pretty beautiful. It's really semantic. So each one of these sessions is just a div with the class name session slot. And internally, it has a time and a title div. And if I just grab their text, that's the data I need. So this will evaluate to the JSON that we saw before that we actually need. So I can do this exact same thing in my automated script inside my Puppeteer script. I can take this exact code, and I can pass it to the page.evaluate method that Puppeteer exposes. And it could be a bit confusing because I'm using Node here, but here all of a sudden we're seeing things like document and query selector all, which are obviously DOM APIs, which only exist in the browser. So even though this function is here as part of my code, it's not actually executed as the rest of my Node script. It's just serialized and sent across, executed in Chrome as if we were to open up the console and type it in there. And whatever this evaluates to is again serialized and sent across and made available as part of my Node script. Then I can do whatever I want with it, and just to clean up nicely, I can close my browser gracefully. So that's Puppeteer. Headless Chrome also works really nicely on if you're using Docker, and also if you like the idea of using a headless browser, but you're not a fan of Chrome for some reason, you should know that Firefox also has a headless mode today as well. Now let's talk a bit about Chrome DevTools. Like I said, it's a tool that I really enjoy using, and I'm sure you're all familiar with it. They have these panels here that have been part of the DevTools UI for at least the last decade, right? The Elements panel, Sources panel, Network panel. But if you haven't had the chance recently to also check out some of these panels that they added to this bottom section, they're kind of hidden, and there's a good chance that there's some use case that you didn't know that they added a panel that solves this for you. So I encourage you to check it out. Now, one thing that's interesting to note about the DevTools UI is that even though it looks just like an integral part of Chrome, it's got that gray background, it's actually written with web technologies. So it's a web application written with HTML, CSS, JavaScript. And what this means is that it's just embedded in Chrome. If you were, as web developers, go to read its source code, and indeed just the source code for DevTools is available in isolation on GitHub if you want to check it out. It's not an easy code base to dive into, but it's using technologies that you know. What this also means, if we know that it's written with web technologies, is that it exists in this sandbox, right? Because a web page has to get data from somewhere. So it's just a front end, it's just the view layer. And in order to get the information about the page that you're inspecting, it has to get that data from Chrome itself. What are the elements on the page that it should display in that DOM, the visualization, etc. So the way this works is that it actually communicates with Chrome as a backend, as a server. And that's the way it's able to get that information. So the DevTools UI and Chrome as the backend exchange messages between the two over something which we call the DevTools protocol. And let's see an example of how this works. So first of all, you have the DevTools front end. We said it's a web application, so the mechanism it's using to communicate with Chrome as the backend is just regular WebSockets. And let's say that you were to open up the console and type in JavaScript command for it to execute. You would just say 1+1. So what the DevTools frontend would do is it will compose this message, a runtime.evaluate message, with the expression being just there as a string. And it would send this very difficult mathematical problem over to Chrome, and then Chrome will evaluate it and return the response, in which time the DevTools frontend can display this. So this is not just some secret implementation detail or something. This is something that's well documented. There's a website specifically for the DevTools protocol, and you're welcome to read more about it. But it's important to note that really everything that DevTools can do, and like we said, it has a lot of different capabilities across all these panels. They all have to be executed based on the DevTools protocol, because that's the only way it can break out of its little bubble. Now, another neat thing that we have is this decoupling between the DevTools client or the DevTools frontend and what is usually Chrome, the DevTools target. You know, in software engineering, we like to decouple things because of good architecture, and this is obviously a good thing, but here there's a real-world advantage that we have because we have this clean separation. So an example of this would be something that the node.js team realized and utilized. So what they realized is that there is such a great debugging experience for client-side applications for JavaScript, and they wanted the same really good experience for server-side JavaScript applications. So what they did is they are essentially making the node process communicate and send back and forth the same messages that the Chrome entity usually provides. And by doing that, they're able to pretty cheaply implement this and get that same nice debugging experience. So the way you would use this today, if you're using a Node, you just launch a Node script the way that you normally do using Node, and you just need to pass in the -- inspect flag. And what you would get is this same familiar UI, but now for your server-side application, this is, for example, a Express server, and you can step through the code like you normally do, use the call stack, add watch expressions, etc. But they didn't stop there, because they realized that there are other parts of DevTools that are useful for server-side applications as well. For example, for improving the performance of your application. This is also a part of the DevTools UI now available for server-side applications. If you're not familiar with this, this is called a flame chart. It's a nice visual way to find the performance bottlenecks in your application. So each one of these bars represents a function call in your application, and the longer the bar is, the longer it took to execute. And it's not just Node.js. Today, you can even debug Android and iOS applications using DevTools, using this same technique where they kind of mimic the behavior of what Chrome normally does. So now we understand a bit more about this ecosystem of the DevTools and the DevTools protocol. We did mention before that Puppeteer is a high-level wrapper for controlling headless Chrome. We didn't really specify how it's able to do that. So by now it should be clear that all that Puppeteer really is, and all it really does, is just send and receive DevTools protocol commands. So it's just a DevTools protocol wrapper. It also takes care of just finding the Chrome executable on your machine and launching it. And the bigger takeaway here is that really all of these neat things that we can do around automating and controlling headless Chrome are all built on top of the DevTools protocol. So if you become literate and comfortable with using the DevTools protocol, you can create new tools and expand what we can do and automate. Let's see how we even launch headless Chrome. So what you have to do is you have to find the Chrome executable on your machine. This is different based on your operating system, of course. Then you need to pass in the headless flag, the remote debugging port, which we'll talk about in a minute. And you can also specify the URL to load as soon as the headless browser launches. Obviously, later you can navigate away using DevTools protocol commands, but this is just a nice way to get started. So I'm going to launch this. And before I hit the return here, I just want you to think what you expect to have happen when I launch this. So if you thought that something will happen, then you're wrong, because nothing happens. This is just a headless browser, so nothing really happens. But I did specify that remote debugging port. So let's see why this is useful. What I can do is I can, over that same port, access it as HTTP. And we did say that it should launch the conference website. And indeed, we have here, it says Øredev 2018. So now I want you to think, by the way, this is just regular Chrome. Okay, this is not the headless Chrome instance. This is just a browser I'm using to navigate to this endpoint. So now I want you to think what you expect to see when I click this here. So if you're thinking that we're going to see the Øredev website, well, that's not it. But if you're thinking that you're going to see DevTools, then yeah, you're correct. Because Headless Chrome is expecting to get DevTools protocol commands, it's already exposing this DevTools for us, which is the easiest way to start issuing DevTools protocol commands. So this is not standard DevTools. This is the one inspecting the Øredev website, which is running inside of Headless Chrome. Other than that, it's a completely regular version of DevTools, with the one exception that I have this extra button here called Toggle Screencast. And what this is only available when I'm debugging a remote experience like this. And when I click this, I get this immediate feedback that's showing me what is rendered inside of Headless Chrome. Because it is rendering things to memory, I can always tell it to send me an image of what you're seeing. And I can pretty much use this as a regular website. I can scroll up and down. I can click things. And any action I do here is sent across as the DevTools protocol command. And I'm getting that live preview back. So I want us to think a little bit about this and how this can be useful. if you think about it, this is how I imagine it. So we have Selenium, which has been around for a long time as the way to control browsers. Because it's meant for testing, it really focuses on providing abilities to create parts of the browsers that the user would normally use. We also have Puppeteer, which supports a subset of what Selenium supports. It's a fairly newer project. It does support some things that Selenium doesn't have. But overall, they're both using just a small part of the DevTools protocol. I put Selenium as a consumer of the DevTools protocol here because when you're using Selenium with Chrome, you're using the Chrome driver for Selenium. It's also based on top of the DevTools protocol. So what this means that in this outer circle here, we have parts of the DevTools protocol that we're not really using by Selenium or Puppeteer. And we need to think, is it because they're useless or because there's just like unutilized parts here that we can really benefit from using? So I'd like to give an example of the type of custom automation that we can create that's actually useful. But I first want to show this extra project. This is also a project by Google. It's called Lighthouse. You might be familiar with it. It's what exists today when you go to the audits panel inside of Chrome DevTools. And what this lets you do is it kind of takes your website and tests it against some known best practices and give you insights that you can use. It's available here to be used manually, but it's also available as a node.js library so that you can put it in your continuous integration server and get a feedback and have it running to catch problems early. And one of the points of frustration with and the limitation of these types of tools is that they have no choice but to treat all the websites in the world the same. So they're really made to just go to a page, wait for it to load. We already said that waiting for a page to load is also not always clear how we define that the page has finished loading, but let's say that we wait a sufficient amount of time, and then it's able to run these tests and give you some insights. But this type of shelf ready-made tool that's available for everyone, it can't always be correct for any website because your website is unique, right? There's something that you're doing that maybe you're downloading extra assets more than you need because you know that you're going to use them later, and suddenly Lighthouse gives you a bad score. So you decide, okay, this isn't for me. You don't measure it. You don't do anything with it. You can't use Lighthouse as is, so you do nothing, basically. So let's see an example that's going to use those other unutilized parts of the DevTools protocol where we would need to have like automation logic that's really aware of our unique website. So for example, let's say that we have these features that are about not just exposing new parts of UI, where we have features that developers really enjoy working on, like making our site faster or more secure or more accessible. So let's say that our goal is to get rid of the amount of unused CSS that we have on the page. It's like, let's say that before we were using a library like Bootstrap, we hardly ever used anymore, but we're still sending down all those bytes to the client, and it's really just a performance overhead that we don't need. So the naive approach is just to find all that unused CSS and just get rid of it. But if we really want to treat all these extra non-UI features as first-class features, then we also need to write a test for them. So what I'd like to do now is assume that I'm taking the time to clear out all of my unused CSS and also write a test for it. So I set this threshold, and if I cross this amount of unused CSS, I will break my continuous integration server or get an email or something like that. So how would we approach that? So the first thing to notice, and to illustrate this, I'm going to take you to a website of a conference that I'm launching next year to compete with Øredev. As you can see, it has an amazing website. And the first thing that we need to know is that Chrome has this ability with the coverage panel. And what I can do here is I can start this recording. And I don't know if you can see if it's big enough or not, but it shows me that 54% of the CSS on this page is unused. Now, this is an outrageous number, right? Because more than half of the CSS that I'm sending down is unused. But like I said before, this is the type of insight that we can get from a tool like Lighthouse. All we did was load the page. But being familiar with this unique application, I know that I'm actually sending down more CSS than I need after the initial page load. And indeed, if this is giving me a live recording when it's tracking the coverage. So as I'm clicking each one of these tabs here in my amazing conference website, the amount of unused CSS starts to drop down until it reaches 14%. So now let's say that this is what I would like to use as the baseline. So let's say if I cross 20%, give me that alert that I want. So how can we do this? Well, we know that DevTools can do it because I just did it manually. So because of what we learned about the DevTools protocol, we know that there has to be a way to achieve this via automation just by sending DevTools protocol commands. So what I can do is just figure out what are the DevTools protocol commands that are being sent across when I start and stop this recording. And how can I achieve that? Well, we know that DevTools is just a web application, so we can do what we always do when we want to understand how a web application works, and that's use DevTools. So what I have here are two versions of DevTools. The one on the bottom is inspecting the web application at the top. The web application at the top just happens to be DevTools as well, inspecting what is happening inside of Headless Chrome. So now if I just refresh everything, I did mention before that DevTools is communicating with Chrome using WebSockets. I can see the raw WebSocket frames that are being sent over. So now if I click the Start Recording, Stop Recording button, I can see that the DevTools protocol command for starting the tracking, the coverage tracking, is called css.start rule usage tracking. And the command for stopping it is css stop rule usage tracking. And now that I have this information, I can get down to write my custom automation, which will give me this threshold whenever I need it. So let's review it now. The first thing I would do, as before, I'm using Puppeteer. I'm launching my browser, opening up a new tab. Now I want to send raw DevTools protocol commands. I can do that with client.send. I have this issue of domains here. So I did mention that the command I want to issue is css.start rule usage tracking. This means that the domain for it is the CSS domain, and this is an unfortunate implementation detail that you do have to be aware of. It's not very discoverable. And also, the CSS domain is dependent on the DOM domain, so you have to enable it as well. If you get this wrong, you'll get a friendly error message back, so don't worry too much about it. But once I enable the domain, I can do what I really wanted, which is call css.start rule usage tracking. Now, what this will eventually give me is the information about which parts of my CSS were used. And I wanted a percentage, right? A ratio between the amount used or the amount unused out of the total amount. So in order to get that total amount, what I would have to do is something like this. I can add an event handler for whenever a new style sheet is added to the page. And that's going to contain that style sheet variable, which will contain information about the size, the total size of that style sheet. So I'm just storing that in the style sheets array. Now I'm going to navigate to my amazing conference website. And this is crucial. I'm also going to mimic those user actions that are relative to this particular website that's going to make sure that I get the real amount of unused CSS and not just after page load. Then I can call stop rule usage tracking, and that actually is something that I get something back. I get that rule usage object, which is an array of all of the ranges inside of my CSS which were used. In order to get this as a percentage rounded up to the nearest integer, something that's friendly to look at, I'm taking these two objects, the rule usage object, two arrays really, the rule usage array and the style sheets array, and I'm passing them to a function I don't show here just because it's boring and it doesn't touch Headless Chrome and it's just doing some primary school level math, which is called calc unused CSS. I'll have a link at the end if you want to see the complete code. And this is all I need basically. Now I will have an automated script that I can run in my CI, which is going to tell me the real amount of unused CSS. So let's just demo this quickly. If I, wait, sorry. Oh boy, Mac keyboard. Sorry about that. So if I run this, it'll tell me 14% of my CSS is unused. And just to show that this is really working, if I run it again, if I comment out these lines that tell it to interact with the tabs in my conference website, it's going to give me that 54% of my CSS is unused. So just to recap, if you're using Selenium today and you're not happy with it, you should consider trying Puppeteer for your tests. It does only target Chrome, but it may be worth the extra stability you get. If you like the experience of using DevTools and you're working with Node or one of these mobile platforms that I mentioned earlier, you can actually reuse the DevTools UI to debug those experiences as well. And also, think about this the next time you develop a feature, if you can, especially if it's not a feature that you can write a simple Selenium test for, if it's one of these performance or other non-UI features, think about if you can write a custom test for it based on this approach. And just think about how rewarding it would be if one of your coworkers accidentally undoes your work in, say, a month or a year. Then maybe like a few minutes after they commit, the CI will send them an immediate Slack message saying, hey, I know what you're doing. I see everything. Revert this immediately. It's pretty rewarding. I put up this resource here. This is a link with a few extra resources about Headless Chrome and Puppeteer, and it will also contain the links from this slide deck. It already does. And I encourage you to reach out to me, especially in the conference, of course, as well. But if you get home in a few days and you actually start tinkering with this stuff, you need someone to talk to, feel free to reach out on Twitter. Thank you very much.